Welcome back, friends. In the last video we started studying about halogens and their compound. We looked at the introduction to the halogens, the general properties of the halogens, and the trends down the group 7. Now in this lecture we'll be looking at fluorine. The symbol of fluorine is represented by capital letter F with an atomic number of 9 and 18.998 as the atomic weight. The electronic configuration of fluorine: helium 1s2, 2s2 and 2p5. In the last video we learned that halogens are the group 7 elements, and the elements are fluorine, chlorine, bromine, iodine and acetylene. As we've said, today we'll be looking at fluorine. Fluorine is the first and the most reactive element among the halogens. Fluorine does not occur free in nature because of its high reactivity. It is mainly found in compounds like cryolite and fluorspar. Very quickly, we'll be looking at the preparation of fluorine. The major method of preparing fluorine is electrolytic oxidation. The electrolyte used is a solution of potassium fluoride in anhydrous hydrogen fluoride. The carbon atom is used as the anode and a steel vessel as the cathode. This is the schematic representation of the preparation of fluorine. Here we have the molten solution of potassium fluoride dissolved in hydrogen fluoride. This is the anode connection, in which we said is a carbon atom. We have the cathode, which is a steel vessel. Here we have the hydrogen fluoride inlet, in which the hydrogen fluoride is passed into the electrolytic cell. Here we have the hydrogen gas outlet, in which the hydrogen gas is being collected. We also have the fluoride gas outlet there, in which the fluorine gas is being collected. We have the cell cover, which is used in covering the electrolytic cell. Here we have the cooling jacket, and likewise we have the gas separation skid, which is used in separating the gases formed. Now what happens here is that electrolysis causes hydrogen fluoride to decompose, forming fluorine gas at the anode and hydrogen gas at the cathode. We said fluorine gas is formed at the anode and hydrogen gas at the cathode. This is the reaction that occurs at the anode, leading to the formation of fluorine gas, and also the reaction that occurs at the cathode, leading to the formation of hydrogen gas. It is necessary to keep the two gases formed, that is hydrogen gas and fluorine gas, separated to prevent their explosive recombination to reform hydrogen fluoride. The gas separation kit is used in the prevention of the two gases formed to recombine to form hydrogen fluoride. Now water must not be present because it will react with the fluorine gas formed. There must not be any traces of water or elements of water in the electrolytic cell, because it will react with the fluorine gas formed. Now, properties of fluorine. Fluorine is a poisonous yellow gas with an irritating smell. Fluorine has a boiling point of -188 degrees Celsius. Fluorine is the most reactive element on Earth. Fluorine is not only the most reactive halogen, but it is the most reactive element on Earth. It combines directly with all non-metals except nitrogen, oxygen, helium, neon and argon to form fluoride of PF6 and SL6. Fluorine displaces all other halogens from aqueous solutions of their compounds. It can even react with noble gases like krypton and xenon. Fluorine is a powerful oxidizing agent, that is, it has the ability to attract electrons from other elements and itself being reduced in the process. For example, fluorine oxidizes water to hydrogen peroxide and itself reduced to hydrogen fluoride acid. At room temperature, fluorine reacts explosively to give hydrogen fluoride. Fluorine is also the most electronegative element in the periodic table, and this electronegativity and electron affinity decreases down the group. That is, the electronegativity and electron affinity decreases as we move from fluorine down to chlorine, down to bromine, down to iodine and acetylene. Now we will look at the uses of fluorine. Fluorine compounds such as sodium fluoride is used for fluoridation of drinking water, and tin 2 fluoride is used in many toothpaste to prevent tooth decay. Now, some cities add fluorides to their water supply. By doing so, they hope to improve the dental health of everyone living in the city. The process of adding fluorides to public water supplies is known as fluoridation. Now, if you remember, we said fluorine is a poisonous gas. Therefore, small amounts of fluoride is added to the public water supply and our toothpaste to help to prevent tooth decay or reduce tooth decay. Fluorine and hydrogen fluoride are used to make uranium hexafluoride, which is used in separating isotopes of uranium. Uranium is used in nuclear reactors for fuel. Without fluorine, scientists couldn't get pure uranium. Another use of fluorine is that fluorine compounds like hydrofluoric are used in etching glass and in cleaning steel. This is an etched glass, and what we meant by etching of glass is the process of cutting or designing the surface of a glass. Now, artists use fluorine when they do this kind of pattern or design on glass. And lastly, fluorine compounds are used as refrigerants and as propellants. This brings us to the end of this lecture. Thank you for watching this video. See you on the next one. If you have any question, feel free to drop your questions on the comment section, and don't forget to subscribe.